Consider the function p of x is negative x squared plus 15x plus 30, where x represents the number of widgets in thousands, and p of x represents the profit in thousands. Suppose the manufacturer wanted to know what the profit would be as they sold close to 8,000 widgets. So p of x is negative x squared plus 15x plus 30. And we want to know what happens as we get close to 8,000 widgets. Keep in mind that x is in thousands. A generic definition of a limit is basically saying what happens to the function as x approaches a value. You might ask, well, why can't we just stick in 8 into the function and get the y value? Well, sometimes you can. This happens to be a nice function. And we'll talk about later on when it's a nice function, when it's not a nice function. But we have to learn a method that's going to work for all cases, because sticking in a number won't always work. To do that, what we're going to do is we're going to make a chart. So notice the end numbers, the 7.9 and the 8.1, they differ by a tenth from 8. One step in, 7.99 and 8.01, they differ by a hundredth. And the next ones differ by a thousandth. So as we approach from the left, that's what this is called. I'm glad I used blue of all things. This is called approach from the left. So we're approaching the value of 8 from the left. And over here, the numbers are getting smaller, so that would be called approaching from the right. So as we approach from the left and as we approach from the right, we want to know what happens to our functional value. Is that okay? So what we're going to do is we're going to plug these numbers in, all 6 of them, into our function. There is a fast way of doing it, and that's using a table on your calculator. So let's do that now. So what you want to do is in your calculator, you want to go to y equals. Would that actually be helpful if I show you the keystrokes? So you want to go to y equals, and then you're going to type in the function itself, which was negative x squared. The negative is by the period. Negative x squared plus 15x plus 30, so negative. So that xt theta n is what you want to use for the whole class for the x. So now we have to set up our table. Since our numbers keep changing by a different value, tenths, hundredths, thousandths, as opposed to we're not adding the same number over and over again, we have to manually type in our table. We can't do it automatically. Okay? So to do that, you want to go to second, table. Table is above graph. Oh, I am so sorry, guys. You want to go to second, table set. Bad, Mike. Table set is above window. And the only thing you want to change here is just make sure independent is on ask and dependent is on auto. The table start and the delta table don't matter. So now we want to go to second table. Notice there it says x and y sub 1, so you have to first type in your function before this will work. And as far as the x values are concerned, this is where we type in those numbers. So we'll type in the 7.9, hit enter, 7.99, enter, 7.999. So that's us approaching from the left. And now you do the same thing from the right. So 8.00, was it 00? Yeah, 8.001, 8.01, blah, blah, blah. That's all you're hearing at this point. Look at all those keystrokes. Makes a lovely gift. So what were those numbers? I'm sorry, 80.
86.99, 86.01, 86.001, 85.99, 85.
You're fine.
85.99, 85.89.
89?
Yeah.
That's crazy. So notice as we approach to the left and as we approach from the right, what number does the function seem to get closer and closer to? 86. So to answer the question of the manufacturer, we would say that as X approaches 8,000 widgets, profit is approaching $86,000. Because remember, X and P were both in 1,000. Now if you're still in your table, basically what your tables does is it just evaluates the function over and over again. So it's very efficient for repeated evaluations. So with that stated, why not just put in the number 8? In other words, what is P of 8? So in your table, if you just type in 8 and hit enter, you actually get 86. So this is a case where a table wouldn't be necessary because we could just put the number into the function and we get our answer. But that's not always going to be the issue. We will have to use a table for now. And actually, let me just give you an overview of the class. We always do the hard stuff first, and then we do the easy stuff. So we're in the hard stuff right now. So this is the stuff that takes 30 minutes per example, and then when we hit chapter 12, it takes a minute.